at normal distribution problems, which is pretty much what we were doing with the standard normal curve, only now we're not going to be looking at standard normal curves. So there are 3 steps you need to follow when doing these type of questions. Step 1 is to state the distribution and the values of interest. Draw a normal curve. I want to say when I was checking homework, there were maybe 4 of you that actually drew a picture with every problem. And I told you last class you should draw a picture with every one of those problems. Amelia drew pictures for the warm-up. Not all of you drew pictures for the warm-up. You need to draw pictures. Just get in the habit. You may think it's tedious, but if you're going to take the AP exam, you're not going to get credit if you don't have a picture. Get the picture, a habit. What?
Wasn't the SOU credit? Yes.
I don't do fall. I do winter and spring. Other questions? There was another hand over here. No? All right. So draw your curve. Area of interest shaded. Label your mean, standard deviation, and the boundary values. So drawing pictures like Amelia did in the warm-up, that's what step 1 is. Step 2, perform the calculations. It's going to say show your work. You're going to use your calculator, but like I said last time, you have to write out what you enter in the calculator. Okay? They do give, on AP exams, at least the math ones, because that's all I've ever been taught, how they grade out or how they do any others, they do partial credit. So make sure you put down what you're putting in your calculator. Because if you have part of it correct, you could get partial credit. It's not this all or nothing type thing. And then you're going to answer the question, and here's the one that kids hate. We're going to use complete sentences. We do more writing in this math class than a lot of math classes put together. Can I move it up? And we're going to do an example together. All right, so on the driving range, Tiger Woods practices his swing with a particular... I can read. I can't do this. On the driving range, Tiger Woods practices his swing with a particular club by hitting many, many balls. I can't spell though, apparently. Sorry. Suppose that when Tiger hits his driver, the distance the ball travels follows a normal distribution with a mean 304 yards and a standard deviation of 8 yards. So we're going to answer 2 questions. A, what percent of Tiger's drives travel at least 290 yards? And B, what percent of Tiger's drives travel between 305 and 325 yards? So step 1 is to draw a picture. So we're going to draw our normal curve. Up in the paragraph, it tells us that it's a normal distribution, mean 304, standard deviation of 8 yards. So I'm going to put my capital N so that we know it's normal. I have 304 for the mean and 8 for my standard deviation. So I'm going to label all my little hash marks. At the center is my mean, 304. I'm going to do 1, 2, 3 standard deviations above and 3 below. So 304 plus 8 is 312, plus another 8, 320, and then 328. 304 minus 8 would be 296. Minus another 8 would be 288. And minus another 8 would be 280. Everybody good with how I got my numbers? So then the question is, what percent of Tiger's drives travel at least 290 yards? So 290 would be, say, about here-ish. Is at least mean greater than 290 or less than 290?
Less than.
Greater. This would mean that at the least amount is 290, so we could be greater than 290. So we're looking at all of this over here. And then step 2, so I got my picture. Oh, one thing I forgot. We do want to label the boundaries, so that's 290. And then I'm going to put down what I'm going to enter in the calculator. So is this normal CDF or inverse norm? Which one? Normal CDF. What's my lower bound? 290. What's my upper bound? A big number, whether you use that 1e to the 99 or just a really big number. What's the mean? 304. So this is where it's slightly different than last time. We're not working with the standard normal distribution, so our mean is not 0 or standard deviation is not 1. We have to put in what the problem tells us. 290, 1e to the 99, 304, and 8. So I get 0.9599, so if I round 0.96, I guess I'll go to 4 decimals. I was going to round, and then I decided not to. Sorry. And then I'm dropping my calculator. All right. It does have to be a percent, so we're going to multiply by 100. So it's 95.99%. Anna, what was your question? I'm sorry, I did not hear you. Oh, you're going to hit second and then the comma, which is right above 7.
Okay, thank you.
Uh-huh.
Wait, how do you know when it's like normal CDF and then the other one?
So if it gives you the area under the curve, or it tells you a proportion of observations or a percent of observations, then you're working with inverse norm. If it asks you to find the percent or the proportion, then you want to use normal CDF.
So just percentages you use?
Or if it says proportion. Or what's the area? There's 3 ways they could ask it. All right, and then the last thing is to write it in a complete sentence. I've said this before, I suck at English, so you may do it better than me, but I'm going to give you an example sentence. So I'm going to say about 95.99% of tigers' drives travel 290 yards or more. Like I said, that's me. You can say it a different way. You guys are much better at English than I am. Any questions so far? All right, and then part B, what percent of tigers' drives travel between 305 and 325? So again, I'm going to start with the picture. Label it. It's normal with mean of 304, standard deviation of 8. 304 is at the center. 3 deviations above and below. And then this time I'm just going to copy my numbers from above. And then we're looking at drives between 305 and 325. So 305 is slightly above the mean. And I'm going to label that 305. And then 325 is almost to that third standard deviation above. And we're looking at that area in between. So then I'm going to put normal CDF. My lower bound is 305. My upper bound is 325. The mean is still 304, and my standard deviation is 8. And I get, bless you, 0.4459 for this one. And again, this one is asking for percent. So I'm going to change it to a percent. So it's 44.59%. And then write it in a complete sentence. So for this one, I'd say something like Tiger's drives are between 305 yards and 325 yards, about 44.59% of the time. Again, that's just a sample way to write a sentence. Questions? Is that better, Trey? Uh-huh. On the next page, there's a set of problems for you to try about, I don't remember how to pronounce that tennis player's name, Rafael Nadal. Sorry, Carter gave me some weird look there, like how do you not know that? Nadal. So, if you're done copying this down, go ahead and try the tennis one for me, please. I'm going to leave this up just a little longer if anybody's still writing, though. Want to go by sixes? Is that your standard deviation? Sorry. I forget they're there sometimes. Make them in paper airplanes sometimes. How was it when it gave you the first time for the area mass? You're trying to see it? Every time. So are you gonna try to play?
I was.
But you're too busy with the job. Did your parents force you to get this job?
I need my shoes.
But what about doing your homework and playing time?
I didn't have a job for a few months, and I changed because my parents had a agreement that I didn't want to take my college, but for reasons what college I go to from private Christian to yoga, so it's a lot more expensive.
Oh, it's opposite. How?
The private Christian school is like $4,000 a year, and yoga is like $1,000.
Usually when you go from private to public, it's cheaper.
Yeah.
What was the school? Oh, gotcha. Got it now. Okay. So now you have to. I'm sorry. That's what CDF. PDF is the equal to. I never realized that it makes so much noise right there. The projector. Like I don't hear all that noise when I'm I honestly thought it was an air conditioner turned on or something. So, you'd think I know all the nuances of my own classroom, but apparently I don't. I'm not sure I can fit under that. Do you even notice?
That's how it is in every class.
Yeah.
I did the opposite when I was exactly like you in the first time. Oh my.
What do you do?
Because yours is like 20.
I'll be there in a minute, Calvin. All right, Bianca is going to put the answer to A up for us. Oh, what the heck is wrong with the normal curve? Those are better. But the lower down.
Yeah.
And then you.
Oh, yeah.
She's like, she's like,
You know, even like a one. What's a negative still?
Let's say you need a really small number. Really big is positive one, really small.
Yeah. It's a pain.
Just 550. Just like mine. Mine started at
What?
4.
So is that public test? I got so me, Alex, and JJ. Yeah, so.
That's not what you wrote there.
I like
Wait, you wrote is correct, but that's not what you have in your
Oh.
Thank you, ma'am. All right, for A, you guys should have gotten 20.23% of Nadal. Did I say it right this time?
Yes.
Serves exceed 120 miles per hour. And about 19.61% of Rafael's serves are between 100 and 110 miles per hour. Most of you had that while I was walking around. Are there any questions? All right. Now, the other thing we're going to talk about today is that you guys need to be able to determine if a distribution is normal. So down below, I have 50 test scores. This is from an old year, but those were 50 test scores from 2 pre-calc classes I taught a few years ago. And we want to determine if the distribution is normal. So when it comes to assessing the normality of a distribution, there are 2 things you want to do. The first one is you want to get a numerical summary. And by numerical summary, I mean the mean and the standard deviation of the data. And then once you have your mean and your standard deviation, you're going to test your 68, 95, 99.7 rule. Because a normal distribution should follow that there is 68% within one standard deviation above and below, 95% within two standard deviations above and below, and then 99.7% within three standard deviations above and below the mean. So we're going to test this distribution to see if it's normal. I apologize, we are going to have to do some flipping back and forth.
Wait, didn't you say that the standard
Actually, we
deviation,
won't. Sorry, hold on.
didn't you think the standard deviation was the sigma?
So, when we're working with, so if you're talking about a population where you know all the data, we use mu and sigma. If you're working with the standard normal distribution, you use mu and sigma. If you're working with a sample, you use x bar and s sub x. So we do use both of them. The Greek ones are if you're working with a population or the standard normal. But if it's a sample, we jump back to those. So, first thing we have to do, we have to enter our data and we need to find the average and the standard deviation. You guys hopefully should remember how to enter data and get your summary statistics. That was from the last chapter. Should remember how to do it.
It's stat. Just hit stat.
Right off 46. Wait, no.
I'm not going through these. It's not like
All right, what's our average? 83.42, what's standard deviation? 10.07. All right, at first I was thinking we'd have to flip back through, but we should be able to use the list in our calculator so we don't have to flip back through. So, now that we have our numerical summary, we're going to test this rule. And we're going to do that on this page. So, within one standard deviation in the mean, we have about 68% of the data. That should be what a normal distribution does. So we're going to actually figure out what our mean plus and minus one standard deviation is. So our mean was 83.42, right? And we're going to add and subtract one standard deviation, which was 10.07. So if I were to, let's see, where did my pencil go? Oh, I gave it to somebody. Where's my pencil? Oh man, Hayden, you took my pencil. I want a pencil. No, it's okay. I want to draw a picture, but I don't know if I'm going to have space to leave it here. So I want to use pencil in case I need to erase. So, if we're thinking about a normal curve, sorry, that was a bad normal curve. We should have 83.42 at the center. And then we would take away 10.07 and we would add 10.07. So this would be 93.49. And this would be 73.35. So what we're going to test is to see if we have 68% of the data in between those two values. Sorry, it's a really bad curve. Now, we don't have decimals on our test scores, so we're going to round. So 73, a score of 73, would be right outside this range. So we're going to look for test scores between 74, not tests, test scores, and then let's see, the other number was 93.49, so we're going to look for test scores between 74 and 93 because we want to be inside the one standard deviation. So we're looking at 74 and 93 because if we did 73 we'd be outside that first standard deviation, and so would 94. So this is where I was thinking we'd be flipping back and forth. We're going to go through and we're going to figure out how many of the test scores fall between those two numbers. But I actually am going to show you an easier way to do it on the calculator. So if you go back to stat, so far I've only taught you the edit in this list, but sort A means sort ascending, so it's going to put it in order from smallest to biggest. Sort D would be sort descending, so from biggest to smallest. So it really doesn't matter which way you put it, but you can sort it so that it's in order. I'm going to go with sort ascending. So if I choose that, it's going to put it back in the home screen. My data is in list 1, So I'm going to tell it to sort list 1. If you put your data in a different list than list 1, tell it whatever list you're in. Okay? And then you hit enter and it says done. And if I go back into my list, so stat edit, now my list is in order. So it's going to be a lot easier to find all the test scores between 74 and 93. So I want you guys to count how many test scores are between 74 and 93 so that hopefully we count the same number. I'm sorry, say that again. Show it again. Is that your same question? So if you go into stat, I chose sort ascending, so smallest to biggest. So you can either hit the number 2 or highlight 2 and hit enter. And then depending on which list you put your data in, you need to tell it the list it's in. So mine's in list 1. So second 1 tells the calculator to use list 1. And then hit enter and it'll tell you it's done. And then if you hit stat and edit, now look at your list, it should be in order. Good? Hannah, you good?
What are we trying to find out?
You need to count how many test scores fall between 74 and 93. Yes, count 74 and 93. Are you guys done counting? What did you get?
38.
38. Everybody get 38? That's what I got too.
I got 39.
All right, 74. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, and then 94 is outside. So I got 38 when I did it before. You got 38, so I'm thinking it's 38. I don't know what happened with the 39. Sorry. So there's 38 test scores between 74 and 93. How many test scores were there? 50. So what's 38 out of 50? Point what?
78.
Isn't it 0.76?
Oh, yeah, my bad.
So 38 of the test scores are between 74 and 93. There were 50 test scores total, so that's 0.76. Or 76% of my test scores fall within 1 standard deviation above and below. Does that make sense, what we just found?
That was 68.
It should be about 68 if it's normal. So we're going to talk about what is within a decent amount. But we're going to test the other two first. Is your hand up or are you just playing with your crutch?
I'll just play with
Okay.
Sorry.
No, it's fine. I just didn't want to, I assumed it was that, but I didn't want to assume and be wrong and then not answer a question. Any other things before we move on? All right, so now we're going to test within 2 standard deviations. So within 2 standard deviations, we should have approximately 95% of the data. So we're going to take our mean and we're going to add and subtract 2 standard deviations. So we're going to take 83.42 and we're going to add and subtract 2 times 10.07. And I'm going to add those numbers to my picture here as well. 10.07 times 2. So 103.56 is 2 above. And then 63.28 is 2 below.
What's the above?
103.56. And then 63.28. And again, our test scores are whole numbers. So I want to look for test scores between, I have to go slightly above this, so between 64 and right below that one and 103. So I want you to go back and count how many test scores are between 64 and 103, and you include the 64 and the 103. Oops, sorry. Did not mean to bump that. Anybody else get 47? Did you really count, Ethan, or did you just see me nod my head to see?
So it was only out of 50, so I just subtracted the last thing.
The last three. That's
Yeah.
how I did it too.
So I did
So we got 3 of us that said 47.
4 of us.
4 of us. Well, that's majority, right? No? Nobody likes my math joke? Thanks, Bianca. Alright, so we get 47 out of 50, which is what percent? 0.94 or 94%. So that's pretty close, right? 94 should be about 95. And then we're going to do our last one, which would be 3 standard deviations, and that's supposed to be about 99.7%, bless you. Average plus or minus 3 standard deviations would be 83.42 plus or minus 3 times that 10.07. Oops. So 3 standard deviations above is 113.63. I cannot type. And 3 standard deviations below would be 53.21. So we're looking for test scores between 54 and 113. All of them are between those two, right? Like Sam said. So that's 50 out of 50 or 100%. So within 1 standard deviation, we had 76% of our data. Within 2, we had 94. Within 3, we had 100% of our data. So just a show of hands. Opinion at this point, no wrong or right, just your opinion. How many of you would say that this is a normal distribution, knowing that 68, 95, 99.7 is the rule that the standard normal distribution falls under, and this distribution is 76, 94, 100. Show of hands. Yeah.
I thought a normal thing was like by 1. It was like 0.
0 and 1.
Yeah.
Right. So if we turned all these test scores into z-scores, we could make it that standard normal distribution. But for now, we're just working with the raw data. So show of hands, how many of you would say yes, this falls under that definition of normal? I got about 4 of you. How many? 5, 6. Okay, saw a couple extra hands. How many of you say no? Alright, so I have about 8 of you, I would say, on that one. This is a normal distribution. So 76 is always the thing that throws kids off. These two are really close to what they should be. This one is not, but it's close enough. She's like, no, it's not. It's not close enough. It is close enough that we could say this is approximately normal. We're not going to say it is perfectly normal. We're going to throw that safety word in there, and we're going to say this distribution is approximately normal. All right, and how many of you, I guess I should finish writing first, sorry. Did any of you like that process? Oh, come on, I gotta have one of you that said it wasn't that bad. All right, you want to know the shortcut? There's always a shortcut. It's math class. Haven't you figured that out? That's how us math teachers work. We show you how to do it. We help you kind of get the conceptual, we're hoping you get the conceptual idea of what we're doing. And then we're like, and here's how to do it really short. That's how math teachers work. So there's a stat plot in the calculator that will tell us much quicker if something is normal or not. So you should still have the data in there. I hope you didn't clear it out. If you did, put it back in. So we're going to make a new graph that we haven't worked with before. So you're going to hit the second y equals, so that we're to this menu. I'm going to work in plot 1. Make sure it says it's on. Okay. And then when you go to the type, you're going to go to that very last icon. That's a normal probability plot. And yes, it is called a probability plot, even though we're not talking about probability. You're going to choose that one. It's because we're working with percents. Anna. Okay. So your data list should be list 1. You're going to leave it as list data access as X. And then you're going to hit graph. Now, some of you may get a graph. I obviously did not. So the way I fix that is by hit zoom 9, and then it puts all my data in there for me, picks a pretty window, puts it in there. Yes, Zach?
It says error window.
Hit quit, hit enter so it quits, and then hit zoom 9. Did that fix it?
Oh yeah.
Okay. Zoom 9 tends to be the fix all for making graphs from data. I didn't almost fall. No, I just hit my heel on hit zoom 9. All right. So when you hit, you have that data in there. So when you hit zoom 9, should look like this if you're working with the same data as me. So normal probability plots, if your data follows a linear relationship, makes a line, then your distribution is normal. So this data makes a pretty good line. It's not a perfect line, that's why we use our safety words. But for the most part, if I were to, let's see, I'm going to be bad. I'm going to draw on my calculator, maybe. Oh, it won't let me. It follows a linear relationship, right? If I draw a line through there, for the most part, it's going to just follow a straight line. Say that
I
again.
feel like a web page marker would
They'll come off the same. Follows a line. Well, that one didn't work as well.
just cleaned up the.
It did clean it up. Anyways, you guys get the idea. If we follow a linear relationship pretty well, it's not going to be perfect. We can say our distribution is approximately normal. Any questions?
Yeah, what that means.
A lot. That's why you don't go to the bathroom in the middle of my class. Gosh. I'll be right there. Okay? So you guys are going to put that data in. You can choose to test your 68, 95, 99.7 rule like we did by counting. Or you can use your normal probability plot to see if this distribution is normal.
So if your data follows a pretty linear line, we can say it's up to.
So instead of doing configuration, I said,
Semi-straight, it's not gonna be perfect.
No, we're
Could
trying
we, we could realize that some of this stuff falls off the line. This one, you guys can do on your own. And
Oh, you're just saying.
So we're gonna talk
so
about
after I
what
put
that
all it in, just do a second Michael.
Yeah, put that data in and grab it.
Me neither.
Oh, please. All right. So,
If you got this, you're almost there. So the calculator has this bad habit of keeping the window from the previous problem. So every time you graph something new, you want to hit zoom 9. Because that looks a lot different than what it first gives you. Okay? Zoom 9.
To reset the window.
Yep. Because it still has the nice window from the previous set of data, and we put new data in. Okay? So make sure that when you're graphing your data, you hit that zoom 9. So does this one follow a line?
Not really.
Not really. It's got a curve, right? And hey, there's this really cool thing about if I were, of course I need to keep my dry erase marker out. If I were to draw a line on this, it would go something like that, right? Which direction does the data fall away from my line? To the right. So this distribution is skewed right because it's falling away from the line to the right. If it fell away from the line to the left, I would know my distribution is skewed left. So if it follows a line pretty well, normal, we can say approximately normal, safety words. Here I would say that this distribution is slightly skewed to the right. I don't know how much skew there is to the right, but because my data is falling away from the line to the right, I have skewness to the right. Does that make sense?
Yes.
Where did I not make sense? Calvin,
We have to like write it down.
do you have to write it down? Like,
How would you
oh. Like if you were answering it, honestly, the way I've seen these type of questions on the AP exam, they tend to be multiple choice. I've never seen one as a free response. That doesn't mean they couldn't do it as free response. But so if it was free response, what I would do is I would make a sketch of my graph. So I have a lot of data down here, right? And it's not going to be perfect. And it goes up through, and then it starts to fall off to the right. And I've got some stuff up there. And then I would say, I'd draw my line through, and I would say that this data, this distribution is skewed to the right, slightly skewed to the right. But like I said, most of the time I see this as multiple choice.
If it's multiple choice, do you just match the graph?
Yeah. So if it's multiple choice, you don't have to show work. You would just circle the one. It'd probably say something like, what's the shape of the distribution? And you would circle the one that says skewed right. Does that make sense? Anna, what was your question? Okay. Tyler?
The last one is normal, right? The exit class one?
I think so, but I don't remember off the top of my head, if I'm being honest.
Obviously,